I am oh my God, my voice. I am a 90s baby, a late 90s baby, a millennial baby. And ever since I got my hands on technology, I have been obsessed. I would say so obsessed, in fact, that it has led me to acquiring a degree in electrical engineering, which is not something that I ever thought I would actually do, and led me to have the opportunity to be a hardware engineer at Microsoft, which is absolutely mind-blowing considering where my journey started. But I was still born at a time where technology was really erupting and beginning to change really and truly the way that we did things. And I've always been fascinated with understanding how our world works, and technology, without a doubt, shapes much of the world that we live in and operate in. The first computer I ever used was a Windows PC, one of them big, thick bitches, with the fat back. And I remember the first time playing just ping pong on the PC and being able to access the internet. I was just sold. I was absolutely sold. And I needed to know, how did this thing work? How was it that I could do all of these cool things on this piece of machinery? I really needed to understand what was going on inside of that box, because to me, this was magic, and nobody around me on the island could explain how this stuff worked, and I just needed to know. I was absolutely fascinated by it, and I needed to find the answers. And I realized in my journey of understanding technology just how uneducated the masses are on the technology that they're using in their everyday life. And it was really, I felt, one of the greatest disservices that the education world has done for just the general public, because technology is disrupting pretty much every facet of human life. I think it's important for people to have some level of technical knowledge to hold engineers accountable for the work that they do, largely because of the work that they do having such a large impact on modern society. Engineers are incredible people, and though they have their best intentions at heart when it comes to building technology to improve the world, I think it's important for regular people that don't work in the technical sector to be able to have an opinion on the way in which technology is progressing. Because if we don't have these conversations, engineers can go ahead and just build a ton of things. Even if they have their best intentions at heart, it may not necessarily encompass all of the attributes that are best for society. And me being born in the information age, I wanted to start my first technical focused podcast talking about the internet. And my hope is that when you finish this podcast, you feel more empowered to discuss technology and have an opinion on its direction and use. I will try my best not to make things too technical as to not bore you to death, but I am an engineer, so bear with me. The longer I spend my time in technology, the more I notice patterns of human development. And the innovation of the internet to me was simply humans doing what humans do best, which is to optimize the flow of information across communities. In the world of technology, a community can be viewed as a network, a series of people or a series of computer nodes sharing insights amongst each other that grants members of that group or users various permissions to access, edit, and create based on that shared set of information. Before the internet, humans invented language, writing, and books to capture, store, and exchange information. But all of these processes have their limitations, the biggest of them being equal access and data integrity over time. Language allowed us to create a central framework to describe our environment, but the use of language before the internet required your presence or having the message be relayed by another source, whether that be a person, object, or piece of technology. Though this helped limit the spread of false information, it did not allow for data integrity and distribution. Imagine if the Bible had never been written and everyone was orally taught their own rendition of its content. We think we got problems now. Books were a great step forward, and this is obvious by their continued use today. Still, writing a book requires more effort, not to mention books require proper storage and transportation to get distributed. Like language, books do not last the test of time, which is important to humans as we try to maintain our collective learnings and history. The internet was the first time anyone could not only author new information, and by information, I'm referring to text, audio, video, software, you name it. But anyone with access to the internet would be able to access that new piece of information and generate their own response that could be viewed by everyone else. No one group controlled the flow of information, and for that, the world would never be the same. A common interview question for someone entering the tech field would be, how would you describe the internet to a child? I often think of it as the Earth's largest library. The internet is the largest collection of human ideas and is stored across the globe. However, other forms of networks exist and are often used that are very much similar to the concept of the larger internet. For example, corporations and institutions often have internal networks that can be accessed only by members within that organization. This form of a network is known as an intranet. If you were forced to study Latin stems like me, you may have noticed that intra is used to mean within, whereas inter is a prefix that refers to between. So the internet is sharing information between networks, while an intranet is sharing information within a network. From the technical sector's point of view, networks can be categorized as local area networks, LAN, metropolitan area networks, MAN, and wide area networks, WAN. A LAN network is a group of computers and network devices connected together, usually within the same building. A common example of a LAN network is Ethernet. A MAN network is a larger network that usually spans several buildings within the same city or town. A college campus like Michigan would have such networks. A WAN network, comprised of multiple MAN networks, is not restricted to a geographical location. And although it may be confined within the bounds of a state or a country, a WAN network connects several LAN networks and can be either limited to the size of an enterprise or accessible to the general public, the most common being the World Wide Web. Because the internet is composed of different smaller networks sharing information, no one person, organization, or government owns the internet. Instead, the internet is managed by various groups with a vested interest in ensuring that the global network is maintained. Still, despite being a global resource, the internet is not truly decentralized as one would like to think. It is for this reason why on October 4th, 2021, Meta and all of its subgroups, including popular apps like Instagram and WhatsApp, were inaccessible to the public, while Google, Amazon, and Microsoft were all still supporting other sections of the larger internet. The internet is actually being stored and updated on a large series of different data servers all across the globe. This dispersed approach helps ensure that isolated climate events and local geopolitics do not impact the stability of the global internet. But exactly how did the internet evolve? Who created it? How has it changed since its inception? And with talks of the metaverse and Web 3.0, where is the internet going? The internet arose due to the need to connect various computers to the same network. I'll likely do a whole separate podcast on the evolution of computers, but I'm sure we all have a general understanding of what a computer is, so when I talk about it, that should not confuse you. Anyways, imagine you have one computer. Though you can write documents or code on it, if you have just that one computer, that information is isolated. Flashing back to various world wars, large governments needed to have networks within their militaries to share vital information across various aspects of their organization, with different sets of permissions to secure different types of information. Data communication via electromagnetic mediums like radio waves and electric wires were not new, as we were quite comfortable with point-to-point communication using telegraphs, aka phones. Still, many advancements needed to be made in our understanding of information theory, such as improvements to signal and noise ratio. This is the idea of limiting as much noise in your data signal, bandwidth, how much information you could send at a time, and transmission error. Was that information sent and received correctly? The invention of the transistor and packet switching resulted in better CPUs, which improved our ability to transmit data at higher speeds. Now, I know there are many layers to the development of technology, but if I go down each one, not only will I bore you to death, but all of that isn't necessarily important to understand the fundamentals of the internet. So, for example, if you want to know more about signal-to-noise ratio, the different types of transistors, or how we convert text to a digital signal that can be transmitted through the air, this is a great opportunity to start doing research. If more people reach out, maybe I can cover, a deep dive on some of these topics, but you would have to let your girl know. Anyways, back to the history of the internet. Though the development of the internet involved the minds of many, the first prototype of the internet was known as Project ARPANET. Developed in the 60s, that's 1960s for my fellow youngins, so roughly 30 years before we existed, Project ARPANET was commissioned by the U.S. Department of Defense and used packet switching to allow multiple computers to share information on the same network. Still, it wouldn't be until January 1st, 1983 that the internet would be open to the public. So far, we know that the internet is a way to share information between computer networks, where all that information is currently being stored on large data centers across the world. But how does that information get to you? After the development of ARPANET, several branches of the US government came together to develop aspects of the Internet Protocol, aka IP. Note, this IP is not short for intellectual property, which is another acronym that leverages IP. When I'm saying IP, in this instance, I'm specifically referring to the Internet Protocol. A protocol is essentially a series of technical requirements required to implement a specific set of features. Many different technologies are explained in their protocols. Technology protocols are managed and amended by large technical organizations like IEEE and the FCC. You can think of it as a technical document that details all required specifications for a technology to function a specific way. For example, different RF technologies like Bluetooth, Wi-Fi, and NFC have IEEE protocols that are available for download on the internet. Internet protocols can be applied across all types of information networks. The IP protocol manages data communication from the host, for example, your computer, to the destination, for example, YouTube's data server, via IP addresses stored in packet headers. You may be wondering if an IP address is the same thing as the URLs you enter to access your favorite web pages. A URL is a uniform resource locator, while an IP is an Internet Protocol address. So a URL connects a user to the website that exists on the World Wide Web. The Internet Protocol is the set of rules for routing and addressing packets of data so that they can travel across the network and arrive at the correct destination. Packets are data traversing the internet that have been broken up into smaller pieces for faster data transmission. IP information is attached to each packet, and this address helps routers send that packet to the right place. URLs are synonymous with domain addresses. Common ones are google.com or bing.com. Every device that's connected to the internet is assigned an IP address, and as packets are directed to that IP address attached to them, the data arrives where it is needed. Every device that connects to the internet is assigned an IP address, and this is the address that packets use to ensure that data arrives where it is needed. Why do we use the Internet Protocol? To understand why protocols are necessary, consider the process of mailing a letter. On the envelope, addresses are written in the following order: name, street address, city, state, and zip code. If an envelope is dropped in a mailbox where the zip code is written first, followed by the street address, followed by the state, and so on, the post office won't deliver it. Similarly, IP addresses help the network know where your data should be sent and routes the response back to you. The Internet Protocol is composed of 5 layers, which represents the decomposition and transportation of data. This process starts at the application layer, moves through the transport, internet, and link layers till it reaches the final physical layer. Each of these layers have sub-protocols that work together to packetize your data and convert it into computer-based language for action and execution. I think it's best to explain what exactly the Internet Protocol is doing with an example. So let's say you want to watch Netflix. The Netflix Corporation has uploaded its entire arsenal of film and TV files to their data server. This could be a data server that they own, or they could leverage a data server from a third party. For example, Amazon's AWS or Microsoft's Azure. When you access your web browser and you type in netflix.com, you are operating in the application layer, leveraging the HTTP protocol. By typing and submitting netflix.com, you submit a request to your PC with a URL. This URL is converted into an IP address via the TCP protocol. Essentially, the TCP protocol is extracting the key action request by the URL, which is used by the IP protocol to communicate with the data server containing Netflix's landing page. The actual communication of data is handled by the link layer. An example of that would be an Ethernet cable connected to the physical layer, which is the actual server containing the landing page. Once this is achieved, the same protocol is leveraged to transmit the data containing the Netflix landing page back through the transport internet and link layer till it reaches the physical layer of your PC. From which then, you use your PC, you can click on the user profile, which triggers another set of data exchanges. This protocol is enacted anytime you interact with the internet, so ensuring that this protocol is standardized across all different technological platforms using it is really important. Without this, the internet would be unusable and difficult to scale. Everyone would have their own networks with their own protocols, and the flow of information would be difficult. The latest version of IP protocol is known as IPv6. The supply and availability of IPv4 addresses have depleted significantly since the boom of the internet. IPv6 addresses have many more characters and thus more permutations, meaning there are more IP addresses available to be assigned to new devices. The Netflix example I used is actually a description of Web 2.0, commonly known as the social web. In 1989, Tim Berners-Lee coined the term World Wide Web, and Web 1.0 was born. Web 1.0 commonly is referred to as the read-only internet, which was obviously before my time. This was the version of the internet that I grew up hearing about. So early email, AOL, dial-up, pixel-looking web pages, Trey vintage, very 90s, early Microsoft tech vibes. This was the age of Web 1.0. This was the time of being online. It was a new phase for humanity. Anyways, web pages designed in this era were static, which means information only flew in one direction, which is very lame, but we gotta start somewhere. Still, Web 1.0 brought us HTML, creating web developers a whole new career in CS. Thank you very much. Nowadays, you don't even need to know HTML to code a website. You can literally drag and drop. With websites like Wix and Squarespace, you can build a website without knowing any coding language. It's wild. What a time to be alive. In 2004, Web 2.0 emerged and was introduced as the age of social media. Now viewers can interact with the content that they read. They can leave comments and reviews. So, a whole new phase to the internet. Web 2.0 is the current model of the internet being used by the public. So it's what you and I use when we think of the internet. For example, like you're streaming this podcast using Web 2.0. Okay? In addition to HTML, new web development languages emerged that allowed for more dynamic interactions. And some of these languages are Angular, JavaScript, and CSS. So these are additional coding languages that developers can use to make the formerly static, lame web pages more dynamic. So this allows you to click things, have there be responses, color changes, just dynamic movement and engagement on a web page. This is pretty much where history becomes the present, because Web 2.0 has created the world that we currently operate in with e-commerce, social media running rampant, age of misinformation. That is today. But still, Web 2.0 did create some of the world's wealthiest companies with the formation of social media giants like Facebook, now Meta, Twitter, YouTube, and Instagram. Frankly, the next bit I will discuss is still unclear. I have heard a few different versions of what Web 3.0 will be like. I've heard that Web 3.0 will mainly be some, decentralized internet that leverages blockchain technology. I've heard 3.0 will incorporate more machine learning and AI, becoming the semantic web. Still, neither of these consider the impacts of quantum computing, so whether that will be Web 4.0, who knows? Is Web 3.0 the version of the internet that will host the growing virtual landscapes of the VR universe? I have no clue, but it's something to keep an ear out for. In pop culture, we often use a lot of the terms I mentioned interchangeably, and I think it's important for us to have a deeper understanding of what they mean. I only covered the internet, but the internet is dependent on the advancements in a vast array of other technologies, including computation, Wi-Fi, cellular, and more. When data servers go down, like what happened in the case of Meta, it can be a big public problem. As a society, we have grown so dependent on technology for facilitating much of our day-to-day life that we often take them for granted. I have covered the history of the internet in less than an hour, and that greatly misrepresents the actual greatness of human ability captured here. The internet took the mental power of thousands of the world's top engineers and scientists over decades to reach the state we currently exist in today. Not to mention, to build the actual data centers that house and maintain the internet requires a collective effort to source and manufacture with high quality and reliability technical components that took us centuries to understand the fundamental physics of. Human minds figured out a way to transmit and store information wirelessly. Like, damn! I am so grateful. We are so freaking awesome. But with that, this is the end of my first technical podcast. Hopefully, you feel more empowered to talk about the internet and actually have a better understanding of how the internet actually works. If you like this podcast, definitely let me know, because I love talking about technology and I think it's so important for us to be able to really understand what's going on behind the screen. That way, we can have much more interesting conversations about where the world is going and how technology can help design the future.